Good morning, Jr.4. I miss you so much. Today, we're going to explain the congruency. Okay, there are some points we have to know about the congruency. That any two polygons are congruent if their corresponding sides are equal in length and their corresponding angles are equal in measure. Okay, here you have to concentrate if you have a question, their corresponding dots are equal in length. You have to know that sides comes with length and angles comes with measure. What does this mean? Here I have two polygons. What is the name of this polygon? It's a quadrilateral because it has 4 sides, 4 angles, and 4 vertices. Okay, first point, their corresponding sides are equal in length. Right, what does it mean? Here, AD is equals to XL. AB is equal to XY. BC is equals to YZ. CD is equals to ZL. That means their corresponding sides are equal in length. Okay, what does their corresponding angles are equal in measure? Let's check the angles. Measure of angle A is equal to measure of angle X. Measure of angle B is equal to measure of angle Y. Measure of angle C is equal to measure of angle Z. Measure of angle D is equal to measure of angle L. So, when I have two polygons, their corresponding sides are equal in length and their corresponding angles are equal in measure, that means the two polygons are congruent. Congruent, this is what's mean with the word congruent, that their corresponding sides are equal in length and corresponding angles are equal in measure. And this is the symbol of the congruent, which looks like the equal but 3 dashes. Okay, there are some points, other points you have to know. Two congruent polygons should be written in the same order of their corresponding vertices. What does this mean? If I have a polygon A, B, C, D, E, congruent to X, Y, Z, L, M. First step, what I'm going to do, I will write numbers above each letter or each vertices of the polygon. Here I have A, B, C, D, E. So I will write 1 for A, 2 for B, 3 for C, 4 for D, 5 for E. And on the other hand, on the other polygon, I will write also the same numbers in the same order. 1 for X, 2 for Y, 3 for Z, 4 for L, 5 for M. What we're going to recognize? We're going to recognize that measure of angle A is equal to measure of angle X. Measure of angle B is equal to measure of angle Y. Measure of angle C is equal to measure of angle Z. Measure of angle D is equal to measure of angle L. Measure of angle E is equal to measure of angle M. And what about the sides? The sides here, I will take each two numbers beside each other, 1 and 2. What does this side call? It's AB. Other hand, so AB is equal to what? Here we said it's number 1 and 2. Let's check the other one. In the other polygon, 1 and 2 is XY. So AB is equal to XY. What about 2 and 3? BC. In the other polygon, 2 and 3, YZ. So BC is equal to YZ. 3 and 4, which is C and D, is equal to 3 and 4, which is Z and L. So C and D, CD is equal to ZL. D and E, which is 4 and 5, is equal to 4 and 5, L and M. So DE is equal to LM. Okay, there's another side, which is EA, which is 5, 1. So we have to say in the same order, 5, 1. So MX. What if I said EA is equal to XM? It's wrong because EA, it's 5, 1. XM is 1, 5. You have to say in the same order. EAMX. So the two polygons are congruent. We can know from the sides. If the two polygons are congruent, then each side and each angle in one of them is congruent to its corresponding element in the other polygon. If I have two polygons, what does this polygon call? This polygon is a rhombus. This polygon is a rhombus. Here these two polygons are congruent. What I'm going to recognize? First, I will recognize that measure of angle A is equal to measure of angle E. Measure of angle B is equal to measure of angle F. Measure of angle C is equal to measure of angle G. Measure of angle D is equal to measure of angle H. What about the sides? Okay, let's check the sides. Here, AB is equal to EF. BC is equal to EG. CD is equal to GH. DA is equal to HE. Other point, equality of the corresponding sides of two polygons is not enough to get the congruent polygons, but it is needed in addition to equality of the corresponding angles. What does this mean? If I have two polygons, their sides are equal. Their sides are equal. That means that they are congruent? No. Let's check. If I have AB is equal to YXY, BC is equal to YZ, CD is equal to ZL, DA is equal to LX. Is that means that the two polygons are congruent? No, they are not congruent. Why? Because measure of angle A doesn't equal to measure of angle X. Measure of angle B doesn't equal to measure of angle Y. Measure of angle C doesn't equal to measure of angle Z. Measure of angle D doesn't equal to measure of angle L. That means the two polygons are not congruent. Okay, what if we have the angles are equal? The angles are equal. So are they congruent? Yes. Let's check. Here I have parallelogram. Here I have parallelogram. If measure of angle A equal to measure of angle X, measure of angle B equal to measure of angle Y, measure of angle C equal measure of angle Z, measure of angle D equals measure of angle L. So AB is equal to XY, BC is equals to YZ, CD is equals to ZL, DA is equals to LX. So the two polygons, which is A, B, C, D, is congruent to X, Y, Z, L. So the two polygons are congruent. So here again, if I have two polygons and their sides are equal, the two corresponding sides are equal of the two polygons. So are they congruent? No, they are not congruent. But if their sides are congruent, equal, if their angles are equal, so they are congruent. There are some special cases. First, the square. Here, two squares are congruent if the side length of one of them equal to the side length of the other square. Here I have two squares, A, B, C, D, and X, Y, Z, L. You know, as we know before, that the square, they have the four sides are equal in length. Here, AB is equal to BC, equal to CD, equal to DA. And AB is equal to XY. So XY is equal to YZ, equals to ZL, equals to LM, equals to AB, equals to BC, equals to CD, equals to DA. The 8 sides are equal. This 4 sides and these 4 sides, they are equal. So are they congruent? Let's check why they are congruent. As the 4 angles of the square are 90 degrees, so if the side length of one square is equal to the corresponding side length in the other square, then the two squares are congruent. Why? Because here the angles of the square are 90 degrees. We said before, if the corresponding angles are equal, so the corresponding sides are equal and they are congruent. Here is 90, and here is 90, and here is 90, and here is 90. And the other square, the four angles are 90. And the four sides are equal in A, B, C, D. Also, they are equal to X, Y, Z, L. So the two squares are congruent. That means, again, two squares are congruent if the side length of one of them is equal to the side length of the other square. So ABCD is congruent to XYZL. Let's check the second special case, which is the rectangle. Two rectangles are congruent if the length and width, which is the two dimensions. Again, if he wrote to me two dimensions, that means length and width of one of them equal the length and the width of the other rectangle. Here I have A, B, C, D, and X, Y, Z, L. Here, as we know before, each two opposite sides are equal in length. Here, AB is equal to DC, and AB is equal to YXY. So AB equal to DC equal to XY equal to LZ. And here is AD is equal to BC. And as we see, AD is equal to XL. So AD equal to BC equal to XL equal to YZ. So are they congruent? Let's know why are they congruent. As the four angles of the rectangle are 90 degrees, so if the two dimensions of one rectangle is equal to the corresponding two dimensions in the other rectangle, then the two rectangles will be congruent. As we know before that the angles of the rectangle are 90 degrees, it's a right angle. So this rectangle, the angles are 90, and this rectangle, their angles are 90. And the sides are, the two dimensions are equal in the first rectangle and the second rectangle. So the two rectangles are congruent. So A, B, C, D is congruent to X, Y, Z, L. Okay, the third special case, which is the triangle. Equality of corresponding sides of two triangles is enough to be congruent triangle. This is because the equality of the corresponding sides of two triangles leads to the equality of their corresponding angles. What does this mean? As the three sides of one triangle are equal to the corresponding side of the other triangle, so the three angles of the first triangle are equal to the corresponding angles of the other triangle. That means if I have here triangle ABC and XYZ, AB is equal to XY, AC is equal to XZ, BC is equal to YZ. So, because I have three sides are equal in the two triangles, so these two triangles are congruent because equality of sides, equality of the sides lead to equality of the angles. So the two triangles are congruent. So ABC is congruent to XYZ. Let's check an example. In the opposite figure, if ABC congruent to XYZ, complete. Here I have two triangles, A, B, C. Measure of AB is 3 centimeter, measure of BC is 5 centimeter, and measure of angle B is, it's a right angle, which is 90 degrees. Measure of angle B, congruent to measure of angle what? And equal what degree? Measure of angle A is congruent to measure of angle what? Measure of angle Z is congruent to measure of angle what? AB is congruent to what and equal what centimeter? BC is congruent to what and equal what centimeter? First thing, what we're going to do, we're going to write the numbers above each letter of the vertices of the triangle. So we're going to write above A, 1, above B, 2, above C, 3, above X, 1, above Y, 2, above Z, 3. Measure of angle B is congruent to what? B, it has number what? Number 2. So measure of angle B is congruent to measure of angle which angle in the other triangle, which is XYZ, has the number 2? It's Y. So measure of angle B is equal to measure of angle Y. Okay, what is the measure of angle B? It's 90 degrees. So measure of angle B is equal to measure of angle Y equal 90 degrees. Second one, measure of angle A is congruent to what? A, it has number 1. Let's check the other polygon. Which angle has the number 1? It's angle X. So measure of angle A is congruent to measure of angle X. C. Measure of angle Z. Z has number what? 3. Which one has number 3 in the other polygon? It's C. So measure of angle Z is equal to measure of angle, is congruent to measure of angle C. Here, the side AB is congruent to what? AB. So 1, 2. Let's check the polygon, the numbers. AB, it's 1, 2. The other polygon, which one has 1, 2? X, Y. So AB is congruent to X, Y. AB is equals to what? Equals to 3 centimeters. That means XY is equals to 3 centimeters. Okay, what about BC? BC, which is 2 and 3, is congruent to what? 2 and 3, which is Y, Z. Okay, so BC is congruent to Y, Z. Equal what centimeter? Let's check. BC equals 5 centimeter. That means YZ is equals to 5 centimeter. Second thing, the axis of symmetry. It is the line when we can fold any figure into 2 congruent parts that match exactly. It is called the axis of symmetry or line of symmetry. There are some geometrical figures, their axes of symmetries are known as. What does axis of symmetry means? It means that you have a polygon, you can cut it into 2 equal parts, matches to each other, which is congruent to each other, matches exactly. But there are some geometrical figures we can know, like the parallelogram. It has 0 axis of symmetry because we cannot cut the parallelogram into 2 equal parts, into 2 congruent parts. We cannot fold them on each other. Scalene triangle. Also, it has 0 axis of symmetry. Trapezium. It's also 0 axis of symmetry. Isosceles triangle. It has only 1 axis of symmetry. Isosceles trapezium. It has only 1 axis of symmetry. Let's make something. If you see isosceles trapezium or triangle, any word isosceles, it means you have only 1 axis of symmetry. Okay. If we have rhombus, the rhombus, it has 2 axes of symmetry. As you see, 1, 2. We can fold them on each other. Rectangle. The rectangle, it has 2 axes of symmetry. Here, the first one and the second one. We can fold them together. 1 and 2. We can fold them together. Equilateral triangle. It has 3 axes of symmetry. Why? Because the 3 sides are equal in length in the equilateral triangle. So we can have, here's the first axis of symmetry. We can fold them together. Here's the second axis of symmetry. And this is the third axis of symmetry. The square, it has 4 axes of symmetries. 1, 2, 3, 4. Okay. Regular pentagon. As we know before in the first term that the pentagon, it has 5 sides, 5 vertices, and 5 angles. If we have a regular pentagon, that means it has 5 axes of symmetry. If we have the word regular, we have to check regular what? He told me pentagon. So if he had pentagon, it's 5 axes of symmetry. What about regular hexagon? Let's remember, hexagon, it has 6 angles, 6 sides, and 6 vertices. So regular hexagon, let's remember, hexagon, it means 6 sides. Hexagon, it means 6 sides. So 6 sides, 6 angles, 6 vertices, that means 6 axes of symmetry. So if you have regular heptagon, let's remember, heptagon, it has 7 sides, 7 angles, and 7 vertices. That means heptagon, it has how many axes of symmetry? 7. Regular octagon, it means we have 8 axes of symmetry. Okay, now we have finished our lesson. Thank you so much, Junior 4, and hope to see you again. Bye-bye.